Hello. This tutorial will be on using Spring Boot with JPA and Hibernate. We will create an application that is able to send and receive data via HTTP to do a specific job, otherwise known as a microservice. Since we're using Java in 2020, we'll use IntelliJ as our IDE. This application is going to store information about farms and about how many potatoes grow on those farms. We want to be able to send an HTTP request to our application and get information about farms and whatever potatoes are growing on those farms. We can define two model classes, which will be JPA entities. We define a farm class with the @entity annotation to say that there should be a farm table in the database that corresponds to this class. In an entity class, there should be an ID field that we annotate with the @ID annotation and then provide a generation type. In this case, we'll use identity. From our perspective, that means that the primary keys for these farm objects will be automatically generated for us once we save a farm object into the database. That's good because I want to spend my time doing more important things, like setting up the ability for a farm to have a bunch of potato produce. We'll add a list of potatoes to this farm class and annotate that this will be a one-to-many relationship. We'll also specify that the relationship should use a join table called farm to potato, which is going to hold rows of farm IDs to potato IDs. If you're starting to get hungry for potatoes, me too. All right, we've defined a farm entity, and the potato entity will look very similar. If you had to guess, what do you think that the annotations will look like for the potato class? Although I can't hear your answer, if you're thinking, we probably want to use @entity again, and then annotations for the ID field, I'm celebrating with you. That would be exactly right. We annotate the class with @entity, and we can create a field for the ID with the same annotations as in farm. We will also add a size field, which will be the size of the potato. Awesome. We have created both of our entity classes. They will serve as a way for us not to have to write any SQL in order to be able to persist potatoes and farms to the database. If at this point you're feeling overwhelmed, no worries. All we've done so far is define two classes with some annotations that will allow us to represent the information that we want to store in a database. Now that we've got our potatoes and farms, we may want a way for JPA and Hibernate to write our queries for us so that we don't have to do extra work. Since we're using JPA and Hibernate with Spring Data, with a couple lines of configuration changes, we can use most relational databases and not have to change anything else in our code. The huge benefit of that is that we can use an in-memory database, such as H2, for testing. That means that when we write our code, we can write tests that run against a real in-memory database and not take a huge performance hit for writing to disk. Now that we know some reasons why we might want to have our queries generated automatically, we can implement it using Spring Data. We create an interface that extends the JPA repository class and specify that it will be for farm, and the ID for farm is long. That's literally all we need in order to be able to have a whole bunch of queries at our fingertips. If you're wondering what this interface does, we will end up using it to run queries on the database, aka it's just some Spring magic. Now that we have models and ways to query the database, we can create services which will handle manipulating the data and performing any business logic we need. We'll create a farm service with the @service annotation. We'll auto-wire in the farm repository that has been automatically created for us. We'll create a getFarms method that should return a list of farm objects that are wrapped in a response entity. A response entity has an HTTP status code, a body, and headers. HTTP status codes give information back to whoever sent a request to our server to let them know what our server was able to do with their request. An OK status is generally for a successful HTTP request, where the server was actually able to process the request and nothing went wrong. We're going to use that. We'll call the farms repository's findAll method in order to get a list of all the farms from the database. Pretty awesome. We didn't even have to think about SQL. We will set the farm list to be the body of the HTTP response, and in the background, there's a library called Jackson. That is transforming our farm list into JSON. Jackson just saved us from having to manually figure out how to convert our Java object into something that can be sent over HTTP. Thanks, Jackson. While we're here, we'll create a method to add a new farm with a random number of potatoes and save that farm into the database so that we have some data to read later. That's all great. Now you might be thinking, where's the fun part? That part comes now. We can create a farm controller that will allow our application to receive and process HTTP requests. We add the @REST controller annotation to define this class as containing methods which we want to bind to URLs. We can add an @request mapping annotation to the class in order to specify the base URL that will be put before all of the other endpoints that we declare in this class. Since our farm controller has the @request mapping quote-unquote farms, these methods will be available at localhost 8080/farms. We will create two methods, one to get all the farms from the database and the other to add random farms to the database with some number of potatoes. We set the request mapping to get to indicate that this method should receive HTTP GET request to /farms. We can set the add random farm method to receive all the post requests to /farms. If we start our application now, we can go to localhost 8080/farms and we get back an empty list of farms because we haven't saved any yet. When we go to localhost 8080/farms with our internet browser, that will send an HTTP GET request, which is then directed to our getAllFarms method. In order to further visualize this all in action, we can hook up Swagger into our application. Swagger will automatically detect our controller methods and let us send HTTP requests into our server with a handy UI. In order to set up Swagger, we will add the dependencies for Swagger UI and Swagger 2. We can then add a class and annotate it with the @configuration annotation, which indicates that this class is declaring a method which returns a bean. Then we create a new docket that will be used to configure Swagger. And that's it. Swagger is now live. If we go to Swagger UI that we now have hosted in our application, we can see the farm controller that we made. If we click that, we can see that Swagger has automatically detected that our farm controller has the capability to receive two kinds of requests, gets and posts. If you're wondering why we want to have Swagger as part of this example, this next part might help. If we click on the get request area for the farm controller, we can see an example of what that endpoint can return. And if we click try it out, we can send an HTTP GET request to our endpoint, which should at this point return the same information that we saw when we went to localhost 8080/farms on our browser, because both are sending a GET request, which is then mapped to our getAllFarms method. Cool. We can see that the response body is empty, and we have gotten our status code of 200 to let us know that our request was processed successfully. Shall we put some data into the database and then see if we can read that data back? If you said, no, I need a cookie instead, I also need a cookie, so I'll be right back. Okay, I'm back, through the power of editing. Let's put some data into the database with Spring Magic. Step 1. We open up the post area, and then, just like what we did with the GET request, we click try it out and then execute. It worked. The return status code was 200, and we can see in the response body that we have a JSON object, which represents our farm. It contains an ID of 1 and a list of potatoes. Since we did not generate the ID of the farm, we know for sure that since the ID is specified, that 1 is actually coming from the farm that was stored into the database, and we have successfully read that data back out. Those are the basics of creating web services with Spring Boot, Spring Data, JPA, Hibernate, and Swagger. In case anyone wants to refer to the code used in this video, it can be found on GitHub, and the link is in the description. If anyone wants to see more of these videos, let me know in the comments. Thanks, and this has been a Programming with Gusto production. Happy coding.